Hello, everybody. So what we're going to be looking at today is the practice problems for midterm number 2. So first of all, it says chapter 4.7 to 5.2 here. That's not correct. Like that's from a different textbook. We're looking from 8.1, which is graphing, up to like 9.2, which is the second section of what's it called? Identities. That's what it is. Um, so let me just open up a web browser here. Let's go back. Um, I guess I can scroll through and point out those sections, right? So if we look at the textbook here, you can see what sections we're talking about. Graphs of the sine and cosine functions, graphs of the other trig functions, which I think does not actually appear on here, and then trigonometric identities, um, just using simple ones and sum and difference identities. So yeah, I mean, that's about it. It doesn't cover that much material, but it is what we have to cover. So that's what we'll be looking at. That's just another copy of the exam. Um, you're probably, or we're probably going to need the unit circle. So I'll download that. And also we're going to need a copy of our identities probably. So I'm just going to download those as well, and then we'll get started. Modules, handouts. What did I just download? Cheat sheet. Okay, so that should be everything we need. We will refer back to these when we need them. Let's go ahead and get started here. So we start out with trying to find exact values for amplitude and period of a function. Sine function or a cosine function should work the same. So if you look down at problem 2, just because that has a graph, I will draw what we're doing here. So this distance from one peak to another peak, that is one period. And the amplitude is half of the height. So like on this function right here, this value is up at 4. This value down here is at 0. And so half of that height would be 2. And so we will use that fact later on. Now, I was just pointing this out because one amplitude here and one amplitude here, because it helps us get them from this equation. So the formulas you would use in order to do this would be as follows. So looking at a function that's y equals a sine or cosine, b x minus c plus d, like this, what you have is that the amplitude, which we saw on the picture, what that looks like, but the amplitude is the absolute value of a. The period is equal to 2 pi over the absolute value of b. There's a left or right shift, which is sometimes called a phase shift. So horizontal shift or phase shift is c if you write it in this exact form. And that's actually right by c, because they could ask left or right. And finally, the midline or vertical shift is, well, depending on what you're answering. If you're asking about the midline is y equals d, whatever this number is at the end. If you're asking what is the vertical shift, it's you would say d units up. So those are all the things they can ask you. And we'll just go ahead and do them for this problem. So in order to calculate the amplitude, we're going to need the number out front, the A. So this is the A. So the amplitude is the absolute value of -3, which is 3. That's it. The period is 2 pi over the absolute value of the B. Notice that the B is the number that gets multiplied by x. So in this case, the B is pi over 2. So you have 2 pi over pi over 2. And I don't really need to write the absolute value because that's a positive number. So absolute value of a positive number is just the number. So you have 2 pi over 2. Don't forget that when you divide by a fraction like this one, that dividing by a fraction is the same thing as multiplying by the reciprocal of the fraction. So this is 2 pi times 2 over pi. Get a color here. The pi's would cancel. And you have 2 times 2, which is 4. Feel free to do this on a computer if you need to. You can use like Wolfram Alpha or something like that. For example, if I load up Wolfram Alpha, you do 2 pi over parentheses pi over 2, like that. And result is 4. So, feel free to use a computer if you need to. Okay. So now we need to write the equation of a sine or cosine function to describe this graph. So first of all, you have to decide whether to use a sine or a cosine. And the easiest way to do that is to look kind of where the function starts. So normally the sine function starts at its midline, and it's going to go up and then down, then up, then down, and so on. And of course it goes the other way as well. But the point is that this point right here is, halfway, the halfway point there. So this is what y equals sine x looks like. Whereas if you look at a cosine, just the basic cosine starts out at the top. I'm saying basic because it can be moved left, right, up, down, etc. And this starts out at its peak there. And so this is y equals cosine x. So when I look at this one here, I can see that it's starting out at a peak at the y-axis there. And that tells me that I want to use a cosine, not a sine. So already I'm going to start with, it should be, I'm going to write it and then we'll change it. Y equals a cosine bx. I wrote it too big because I'm dumb. I'm going to start over. Right, we're trying to do y equals a cosine b x minus c plus d. So it seems very complicated, but we're going to find each of those things, and it's not that complicated. So let's start out with the a. So the amplitude here, by definition, is equal to 1/2 of the maximum value you see on your graph, maximum y value, minus the minimum y value. So what that's going to be is 1/2. The maximum y value is 4. The minimum y value is 0, right down here. And so we have 1/2 4 minus 0. 1/2 of 4 minus 0 is 1/2 of 4, which is 2. So the amplitude here is 2. Now you could have just looked at it, right? Remember how I said this is one amplitude and this is one amplitude. So from 0 to 4, well, half of that is 2. So that's all we're doing there. So the amplitude is 2. And then we also know that the amplitude, which is 2, should be the absolute value of a. So a needs to be either 2 or minus 2, one or the other. And there's no reason to make it negative. Making it negative would flip it upside down. So like if you wanted to graph, like let's say y equals negative cosine, it would be like this. That's what y equals negative cosine x would look like. So don't make it upside down unless you need to. So even though technically the a could be 2 or negative 2, it's not going to be negative 2. It's just going to be 2. So we can come up here and we can fill in the 2. All right, so now we have the correct amplitude. So then the next thing to deal with is the period. So we know that the period measures this distance from here to here. So that's measured on the x-axis. So we just figure out how far that is. So of course, this is at x equals 0, right? This is at x equals 0 here. And then way over on the other side, this dot is at x equals 4 pi over 3. So how far is it from 0 to 4 pi over 3? Well, it's 4 pi over 3. So you start out with the equation that we had before, which was the period is equal to 2 pi over the absolute value of b. Fill in the period. The period is going to be 4 pi over 3. So 4 pi over 3 equals 2 pi over b. And you need to solve this for b somehow. There's a lot of different ways to do it. You can do what they call cross multiplying, where you multiply these two things together and you multiply these two things together and set them equal. So if we do that, this times this, 3 times 2 pi is 6 pi. And the other two, 4 pi times b is 4 pi b. And then if you're trying to solve for b, we should divide both sides by 4 pi. So just go over 4 pi, over 4 pi, and you get b is going to be 6 pi over 4 pi, which is 3 over 2. Again, you can use a computer if you need to for that. So we have b is 3 over 2. So come up here, replace the b with 3 over 2. All right, now for the c. The c is a left or a right shift, that way or that way. But if you look, the cosine, right, it has its peak right there at 0. And if you look at this graph, it has its peak right there at 0. So this has not been moved left or right, right? This is at the peak right here, just like this is at the peak right here. So there is no left or right shift. So no left, right shift means just c is 0. We don't have to worry about it. So we can just erase it. Okay, c is done. Then finally, for the d, that's how far it's been moved up or down. So normally on all of these, let me get a different color here. Normally the middle is right at y equals 0 on these. On this one and this one, sine and cosine, right in the middle. And it could be moved up or down. But on this one, where's the middle of the graph? The middle of the graph is right here, right? And what is that y value? It is y equals 2. So there's a formula for it, by the way, but it's 2. The answer is 2, but there's a formula for it, and the formula is the midline is going to be equal to, well, not the midline. We'll have to write y equals to make it a line, but it's 1/2 the maximum plus the minimum. Now that looks familiar. It looks like this for the amplitude, but it's not, because the amplitude has a minus and this has a plus. Otherwise, it's the same. So 1/2, the maximum is 4 and the minimum is 0. So 1/2 times 4 is 2. So that tells us two things. One, the midline is y equals 2, and also the d is 2. So you come up here and oops, you replace that with a 2. So that's your equation. 2 cosine 3/2 x plus 2, right? Don't need those extra parentheses. So that's your equation. Y equals 2 cosine 3/2 x plus 2. Okay? Yep. All right. So here's another one. This is mostly to get you some practice doing this. Keep in mind that your actual test is multiple choice. So you're going to be picking the right graph off of a list, not having to graph it yourself. But let's go ahead and do this. So period and amplitude is exactly like what we've just been doing. So we know that the amplitude is equal to the absolute value of A. So it's 3, right, based on that. And the period is 2 pi over the B, which is 2 pi over 4. So you do 2 pi over 4. It's 8. You can work that out by hand or calculator, whatever. So that's 8. All right. So, and then there's no left-right shift because there's no C, and there's no vertical shift because of no C, no D, right? So there's no C or D. So that means no left, right, up, or down shift. Okay? So it's centered. Everything is centered. And also notice that this is minus, and like we talked about here, a cosine normally starts at the top, but if it's a negative cosine, it starts at the bottom instead of the top. So what can we say about this? It's a cosine. It's negative, so it's upside down. Its amplitude is 3. So we go 1, 2, 3, 1, 2, 3. So its amplitude is 3, so it's going to go between plus and minus 3. It's negative, so instead of starting up here, it should start down here at 0, negative 3, for example. And then we know what it should do. Starts at the bottom, and then it should go up, and then back down, and then up, and then back down. And then what you have to do is remember what one period looks like. One period is from a peak. Oops, I drew 2 periods. One period is from a peak to a peak, or from a bottom to a bottom, whichever. So here, that means from this point, we should go out however far. Oops, I don't know why I made a line like that. So we should go out like this. How far? 8. So we count 1, 2, 3, 4, 5, 6, 7, 8. That means here. That's an 8. So that's at 8, negative 3, for example. Just from symmetry here, we can figure out some other stuff. So like if you have a peak and a peak, halfway is where it's at the bottom. Or the other way around, since we have an upside down cosine, from here to here, halfway would be the top, right? So halfway between 2 bottoms is a top. So halfway between 2 bottoms is a top. So we should be at, if this is 8, then we should go out to 4 and then up at 3. Like that. And then you can kind of put in some intermediate points spaced evenly, and it should go like this. Continuing that on, the pattern is the same on the other side. So we'll fill in some points. Something like that. Now we can easily check our answer because we can do this on Wolfram Alpha. I wouldn't use Wolfram Alpha, I would use Desmos to check this, but -3 cosine pi over 4x. So maybe we'll come here and I'll go to desmos.com, graphing calculator, and we have y equals negative functions cosine. It was pi over 4 x, and that's it. So looking at it, let me make this bigger. So looking at this, you can see that this point, I didn't have the 3. All right, there we go. So you can see this point is at 0, -3. Kind of hard to see. This point is at 4, 3. This one down here is at 8, -3. 4 is halfway, and then halfway between 0 and 4 is this 2, and halfway between the 4 and the 8 is this 6. So it's the same graph that I graphed, and there you go. So we did 3 of those. You would just have to match it up with a picture given 3 or so pictures. All right, find the exact value shown below. So these are a little bit tedious, to be honest. This one is in particular. What you would want to do here is generally like this. So this is a particularly difficult one. A lot of them you can just kind of evaluate, and you could here, but it doesn't simplify very well unless you do it the way that I'm about to. So normally what I would do here is this. So I would take the inside and I would call that theta. Theta equals cosine inverse -12 over 13. Now take the cosine of both sides, and this will say cosine theta equals -12 over 13. Okay. Then what I would do is I would say, what sides of a triangle give you a cosine? And the answer is the adjacent side of a triangle and the hypotenuse of a triangle. So what I do is I try to draw a triangle that matches that information. So I draw a triangle, and you can try to draw this like on a unit circle or something, but I find that that doesn't work very well, so I'm not going to. So I draw a little triangle, and what I'm going to do is I'm going to say that the hypotenuse should be 13, just from comparing hypotenuse and 13, and then the adjacent side should be 12. Now, what about the minus? Basically, if you have a minus, always never put the minus with the hypotenuse, put it with the other side. So the minus should go with the adjacent side. So if this is my theta, then I'll call this -12. Okay. Now, when you do that, what you're going to be doing is you're going to have a missing side of your triangle, right? We know 2 sides, but we don't know the third side of the triangle. So you have to calculate it. So you use the Pythagorean theorem to calculate the missing side. So like x squared plus y squared. No, I don't want that. I want a squared plus b squared equals c squared. So you fill in the numbers. Let's say we don't know a, but we do know the others. So you fill in the numbers. So this is a squared plus 144 equals 169. You move the 144 over and you have a squared equals 25, I'm pretty sure. And then you have a equals plus or minus 5. Okay? So that tells you that this side is either a 5 or a minus 5. Now, having done that, I've got all of the sides labeled on my triangle. So with the triangle done, I should be able to calculate the tangent, which is what I'm trying to do. Because why would I be able to do that? Well, because I'm being asked to calculate the tangent of the cosine inverse of negative 12 over 13. And that inside, remember what I did with the inside, is I took the part that I underlined and I called it theta. So the part that is right here is just theta. And then that's the tangent of theta, which is the sides of the triangle that give you tangent are opposite and adjacent. So you just read off the opposite and the adjacent sides. So this is the opposite, and this is the adjacent. So opposite over adjacent is 5 over 12 negative. Okay, so I want to say 5 over 12 with a minus, but I do have to be careful here that I'm getting the sign correct. And like this is an unfortunate complication for this problem. This is part of the reason I said this was particularly difficult. So the thing is this. I mean, I think that answer is correct, but you should think a little bit about the signs, because if you remember I'm trying to look for a blank space to draw. I guess I'll draw down here. If you remember when we derived the inverse trig functions in the lecture, what we did was we had to restrict the domain of the functions. So like when we did the inverse sine was only defined in this section of the curve. That was right, sine inverse was only defined for the section of the unit circle that was negative pi over 2 to positive pi over 2. But the cosine inverse was actually this section of the curve, top half. So the in order to do cosine inverse, it was on 0 to pi instead. And so when you do the cosine of theta is negative 12 over 3, on the unit circle, that would have been a negative 12 over 3. That's somewhere over here, 12 over 13. So in order for the x value to be negative, the theta had to be somewhere in quadrant 2. Because it couldn't be quadrant 1, because if it was in quadrant 1, the cosine would have been positive. So it's got to be in quadrant 2. And in quadrant 2, the sine is positive and the cosine is negative. And when you divide them to get a tangent, the tangent is negative. So all of that is to justify the fact that when they told us cosine inverse is negative, or sorry, cosine inverse of a negative number, so cosine is negative, they were telling us without telling us that we were in quadrant 2, and if we're in quadrant 2, the tangent should be negative, and I did get a negative. You should get the sign right if you followed the method that I followed anyway, and you shouldn't have to think about it, but I'm just trying to justify this minus sign here a couple of different ways. So I realized that was pretty complicated. Normally what you would do is if this is a value that you can calculate, like it's on the unit circle, you just calculate the inside and then you calculate the outside, and it's a lot faster than what I just did. Okay. Then we got some inverse trig functions that you're going to calculate from the unit circle or my videos. My videos, I think I give you tables for sine, cosine, and tangent inverse, and those are pretty useful. Well, where did this come from? Well, that's amazing. I was going to try to open the web browser, and instead I opened an old set of notes, and that old set of notes happens to be exactly what we were looking at right now. Okay. So, yeah. So if you're doing sine inverse of negative root 3 over 2, then what that's telling you is that you are trying to figure out in this section of the unit circle, where is the sign equal to negative root 3 over 2? So what theta in negative pi over 2 to positive pi over 2 has sine theta equal negative root 3 over 2? That's what the question's actually asking. And on the unit circle, the sign is the y value. So you just look for a y value. Hey, let me point. I can't point. Oh, why can't I point? You can point here. Oh, weird. So where the y value is equal to negative root 3 over 2 is right here. Right here. So negative pi over 3 is the correct answer there. And that's it. When you do cosine inverse of negative 1, the question is what theta in 0 to pi gives cosine theta equal 1. And on the unit circle, what is a cosine? Cosine is an x value. So where is the x value equal to 1? And we go down to cosines here. I actually have a chart. I didn't have the whole chart for sine inverse. That's why we had to do it the way we did it. But so where is the 1? The 1 is right here. So what is arc cos of 1? 0. Right? Because cosine 0 is 0. Sorry, cosine 0 is 1. Right? Cosine 0 is 1. So that's the correct theta. 0. All right, tangent inverse square root 3, same deal. Did I do tangent inverse somewhere? No, okay, I didn't. Oh yeah, I did. Here we go. Here's a table for tangent and tangent inverse. So this is tangent inverse of root 3. So you find square root 3. Here it is. And the angle is pi over 3. You could also use the table just for tangent, where you look for the root 3 there, and then the angle is, again, still pi over 3. Oops. Pi over 3. Of course, you can use calculators will also come up with these same answers, but you're supposed to be able to do it from a unit circle or by hand, like we just did. Okay, moving on. So I probably should not have started, should have had an easier one before this one. This is actually a very easy problem, but it looks like it's hard. So let's read it. It says, your neighborhood movie theater has a 25-foot high screen. So they're saying height is, I can't draw on it anymore. Let me do this. Okay, now I can. Your neighborhood movie theater has a 25-foot high screen located 8 feet above eye level. So The person looking straight ahead is seeing, no, the person looking straight ahead is looking at the wall. You have to look up a little bit to get to the screen, right? So this is straight ahead and then up a little bit. Okay. If you sit too close to the screen, your viewing angle's too small. By contrast, you sit too far back, the image is quite small. If you sit X feet back from the screen, your viewing angle theta is given by this formula. Find the viewing angle in radians at a distance of 15 feet. There's nothing to this, right? This is the distance, and this is the viewing angle. All they're asking you to do when they say distance is 15 feet, they just mean if X is 15 feet, what is theta? And all you do is you plug in 15 and you calculate it with a calculator. Okay, so that's why I say it's easy. They use all these words to try to trick you, but you're just plugging in 15. 15 is the distance, and the angle is what we're going to calculate, right? The angle, this angle. So let's calculate it. So theta will be tan inverse 33 over 15 minus tan inverse 8 over 15. And yeah, then you just have to punch that into a calculator. They say radian, so make sure you're in radian mode. Or, you know, if you're using a computer, make sure your computer is calculating what you mean to calculate. So we'll go Wolfram Alpha, and we just type it in. So inverse functions, you normally type in as arc, like that, like arctan for inverse tangent, 33 over 15. And then minus, oops, come on, parentheses minus arc tan 8 over 15. So that's it. We just type that in. And this is going to be in radians. 0.65. All right. So that's all we're doing there. All right, just punching it into a calculator and we get what we get. All right, now we're into chapter 9. We're into chapter 9. Chapter 9 is the beginning of identities, so we're going to have to refer to some of them. The ones you need to know are the reciprocal Pythagorean identities. So those are the first ones we deal with. So let's look at our cheat sheet. And they're kind of the ones in the upper left, right? This section, this section. Okay, so when it says simplify, what are we going to do? Well, we're just going to do this. Write everything in terms of sines and cosines and see what cancels. So the cosine, you leave as cosine. The sine, you leave as sine. The secant, what do you do with the secant? What is a secant? Well, you know, look right there. A secant is 1 over a cosine. So that was the reciprocal identity. And you've got a cosine times a sine over a cosine. So what do? You cancel the cosine. What are you left with? Well, the cosines cancel. Just left you with a sine. And that's it. Okay. Now, next one is going to use a different identity. It says reciprocal or Pythagorean. We are probably going to use the Pythagorean. So a hint that you're doing the Pythagorean identities is notice that the Pythagorean identities have like squares in them, right? Sine squared plus cosine squared. Tangent squared plus 1 is secant squared. They all have squares. And so when you see these powers in there, that's a hint that that you might be using a Pythagorean identity. So the way you would do this is you should notice that, I mean, there's a few ways to do this, but yeah, there really are a few ways to do this. But the way I would do it is I notice that there's a cosine and there's 3 cosines there. So I would say you can factor out a cosine. So if you take away these cosines, or one cosine, then if you take one cosine away from this term, then that'll be gone. If you take a cosine away from the cosine cubed, it'll turn into a 2. So you'll be left with cosine squared x plus sine squared x, like that. And then, just looking at your Pythagorean identities, we know that sine squared plus cosine squared is 1. So all of this together is just 1. So we have a cosine x times 1, which is cosine x. Now, factoring out the cosine might be a little bit tricky. If you find that a little bit tricky, here's something you might try instead. So another way to do it would be to say, well, this is a sine squared, and I'm looking at my Pythagorean identity, and it says, off to the side here, sine squared theta plus cosine squared theta is 1, right? So what's a sine squared? If you move the cosine over, you have sine squared theta is 1 minus cosine squared theta, right? Just by subtracting that over to the other side. And if you take this right here, then you can substitute that in for this sine. If you do that, you will have, well, this is going to be cosine cubed plus parentheses. I'm going to replace that sine squared with 1 minus cosine squared. And then I've got a cosine x. So I'm here. Then this cosine is multiplied by both of these. So I'll have cosine cubed plus, well, cosine x times 1 is cosine x. And cosine x times cosine squared is cosine cubed. And then you notice that you have a positive cosine cubed and a negative cosine cubed to cancel out. And you'll be left with cosine x. So there's more than one way to do that, but they all involve using that sine squared plus cosine squared is 1. Okay. Next. So we've got an expression here. It's got a cosine, a sine, and then we notice we have 2 different numbers here, a 25 and a 5, and then another 25 and a 5. And that should look like an identity. So you find the identity on here. It should be a sum or difference formula, which it is, right? It looks like the top one there. I can't really point at that, but it looks like this one, right? Sine A or sine alpha cosine beta minus cosine alpha sine beta. And notice that this is a minus here, which is on the bottom of the formula. And also over here, you have a minus on the bottom of the formula. And so that tells me that sine alpha cosine beta minus cosine alpha sine beta should be equal to sine alpha minus beta. So this should be just referring to the identity, should be equal to sine the alpha minus beta, or I called them a minus b, and then you fill in the numbers. So Wait, hold on. Oh my God, I am blind. I said this matched the first one, right? Obviously it does not. Cosine, 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 sine, sine. And I said it matched the first one, but the first one is sine alpha, cosine alpha, sine beta. It's not cosine, cosine, sine, sine. So obviously it's this one that it actually matches. Okay. And we still do need to pay attention to the minus sign. This is a minus, which you'll notice is on top there, which means when we go to the other side of the equation, we need the sign that's on the top, which is a plus. So this is going to be equal to not sine, it's going to be a cosine here, and it'll be the a plus b, right? Because the plus is on top, which goes with the minus, which is on top, and we have a minus. So cosine a plus b. So it's cosine 25 plus 5. So it's cosine 30 degrees. And cosine 30 degrees, you're supposed to know from your unit circle, which I think I have one. Oh, I do, right here. So cosine 30 degrees, of course, 30 degrees is right there. We want the x value at 30 degrees, which is square root 3 over 2. Square root 3 over 2. And so we applied the sum or difference formula. All right. Next question. So we're still going to use a similar identity. So it says evaluate the expression exactly. Hint, rewrite 7 pi over 12 as a sum of two angles. And I say probably you want to convert the angle to degrees first. And I think you do, because 7 pi over 12, you're not going to know what that is. So you can do that by hand, or I'm actually going to just do it here. It's not hard to convert angles to degrees, but we could do it by save time this way. So 7 pi over 12 in degrees, you can try it that way. It didn't do it. Okay, so I guess we will do it by hand. So 7 pi over 12, that's radians. And of course it should be negative, but I'll just change it at the end. And then what you need to know is that pi radians is 180 degrees. So when you multiply this out, multiply across the top, you get 7 pi times 180. And when you multiply across the bottom, you have 12 in pi. Pi's cancel. So what we're going to get is uh, 7 times 180, 7 times 180 divided by 12. 105 degrees. Okay, now you might be thinking like, okay, well, great. So it's 105 degrees. How did that help me? Well, it helps you this way, because you can say that the sine of, well, negative 7 pi over 12, we know that that is the sine of negative 105 degrees. And when it's written as 105, you can figure out, you're trying to write it in terms of like 30, 60, 90, also like 45, etc. The angles that you know from the unit circle. And so what you realize at some point is that a 60 and a 45, if you add them, you get 105. So this is actually, you could say negative 60 plus, you do plus or negative, I guess. It doesn't really matter. I'll do minus 45. So then your A could be negative 60 and your B could be 45. And then we can use an identity. What identity? Well, we have sine of A minus B. And we can go to our identities, which are somewhere. So sine A minus B. Where are you? Up here. Sum and difference formula. So sine A minus B would be equal to sine A, I'm going to write it, cosine B. And when it's a minus, then this should be a minus cosine A sine B. Okay, and then we have to fill in the numbers. And be careful with the signs here. The way that I wrote this, my A is negative 60, but my B is not negative 45. My B would be positive 45 because the minus was part of the formula and the 45 stood alone. So 45. And then minus cosine A, which is negative 60, and then sine B, which is just 45. And then these angles, you just look up on the unit circle. So back to the unit circle, back to the unit circle. I like my other unit circle better. Do I have it open? Yeah. So if I go to negative 60 degrees, negative 60 degrees would be 60 degrees, but in the negative direction. That's actually where 5 pi over 3 is. So sine of that angle would be the y value there. So negative root 3 over 2. And then cosine 45, is the x value up here, which is root 2 over 2, and then minus what? Okay, cosine negative 60, which is back down here. The cosine is the x value here, which is 1/2. And then sine 45 will also be square root 2 over 2. So you get all those from the unit circle or from a calculator that can do it symbolically. And then what does this tell us? So if you multiply across the top here, you get negative square root 6. On the bottom, you get a 4. On the other one, you have minus 1 times root 2 is root 2, and then 2 times 2 is 4. And something like that is fine. If you want to put them together, you can write that as negative square root 6 minus root 2 over 4. That's fine. So negative root 6 minus root 2 over 4, something like that. Okay. So next question. So this should look like an identity. Again, we're only dealing with certain ones. There's a hint here. And that hint is, you don't need it to start the problem, but it kind of will hopefully point you in the right direction. So it's supposed to, I was trying to point you towards this identity here. So the identity that we have is, here I'll write it the other way around, tan alpha. I'll put the minus tan beta over 1. And if the minus is on the bottom, so the other one that's on the bottom is a plus, tan alpha tan beta equals, the one that's on the bottom is tan alpha minus beta. That's the formula that we're going to use just from the notes. So we have an alpha and a beta, right? That's our alpha and our beta. So that's alpha and that's beta, matching them up with this formula. So if you match them up with that formula, then shouldn't this be equal to the I'll do it below here, should be equal to the tangent of alpha minus beta. So the tangent of pi over 5 minus pi over 30, according to the identity. And then, as my hint said, pi over 5 minus pi over 30 is pi over 6. So this is just pi over 6. So this is tangent pi over 6. And then that you get from the unit circle again, or from a calculator, like this unit circle. So where is pi over 6? Right here. And I know that, the tangent is the y over the x. So it is the 1/2 over square root 3 over 2. So it's like 1 over square root 3. You can rationalize that if you want. It's square root 3 over 3. I don't care. Just a correct value there is fine. Okay. So, of course, the key was figuring out what identity it was in the notes, and only the ones. Remember, the test is only covering some of these, so just kind of the ones in the first 2 sections. So that's like this right here: tangent and cotangent, reciprocal identities, Pythagorean identities, and then specifically these 3 sum and difference formulas. You're not going to have, all of them, but we did on the practice test, I think. Okay, so that is, looks like the end here. We got a blank page at the end. So that's it for the practice test. Hopefully this is useful. The real test is going to be easier because remember, you can use calculator, which I didn't always use a calculator when I could on here. And multiple choice, which will make the graphing easier, and so on. So good luck on that. And yeah, good luck on that. Talk to you guys later.